Hello and welcome to my C programming series. In this video, I'm going to talk about arrays in C programming. First, let's see what is an array. An array is a collection of elements with the same data type. Remember vectors in mathematics? You can store vectors in arrays. Sometimes you want to have a collection of variables in a row, for example, hundreds of integers. Then you should use array. I don't think you can find a program that doesn't use arrays. You might say, okay, I'll go ahead and declare all my variables. I don't need to group them in arrays. In my case, I'm creating a program that has millions of elements. Each element has 4 nodes. Each node has x coordinate and y coordinate values. Imagine I wanted to declare all of them as double or float numbers. How long would it take? And it's impractical and it's not a good way to do it. So arrays are here to help us store big chunks of data. Okay, now that we get the arrays are important, let's use them and make our lives much easier. What we do is we give an array a single name, and through that, we can refer to all the elements in the array. Let's work on some examples. Suppose you want to have an array of 5 integers. I would start with the keyword int and the name of the array. Let's, in this case, just name it array uppercase A. And then square brackets. In the square brackets, I put how many integers I want. In this case, let's put 5. Now I have an array of 5 integers. I basically allocated enough space to store 5 integers. Now to access each integer, I can write the name of the array and then square brackets, something like index. An index is which variable inside that array I want to have access to. I want either read from or write data to that part of the memory. So in this case, I'm going to write 0. Now I'm accessing to the first element in the array. Guys, be careful that in C, arrays always start from index 0. So in this case, array bracket 0 means the first element. Now I'm accessing and I'm about to modify the first element in the array. So indices start from 0 and go to 4. As we declared the array as integer, it means all the elements are integers. Now I'm accessing the first element. I can set it equal to 5, for example. Basically, I'm initializing the first integer in the array block we just created. In terms of memory, I asked for 5 integers. What computer would do, it will look in the memory and find enough space for 5 integers for me. What is the size of 5 integers? If you don't know that, you should definitely watch the video regarding variables. We talked about the first index, which is 0. We haven't talked about the last one. Be careful, as we start from 0, the last index would be 4. It would not be 5. So if I want to access the last element in the array, I would choose array and the index 4 in this case. Printing arrays is simple, as I said. They're just integers. So let's print the first integer and the last one to the screen. So printf. Array 0 is %d, and I'll just print array 0 because it's an integer and it will set instead of %d. And the same thing I can do for all the indices. In this case, I'm going to do it for the last index, which is 4. Press F, Control F5 to compile and run the code, and you would see that array 0 is 5 and array 4 is 4 is being printed on the screen. What would have happened if I go ahead and change the index 5, which is the 6th element in the array? So if I go here and say array 5, so now I'm accessing the 6th element, and I'll set it to 10. And let's compile. Let's debug the code actually. And if I click here, I can see the error. The error said buffer array of size 20 bytes will be overrun. 4 bytes will be written starting at offset 20. What does this error mean? This error means that you specify 20 bytes for your array, which is 5 times 4, because integer size is 4 bytes. Now you wanted to access beyond that 20 bytes that I store for you. And this will be written offset that 20. So you are modifying a part of memory that doesn't belong to this array. This can ruin your code. But Visual Studio in debug mode will error you. But if we were on release mode, if I change this to release and press Ctrl F5, the code will compile and with 0 errors. So there would be no errors here. But you should be very careful. And even in debug mode, some other compilers like the online compiler I gave you won't give you any error. So you need to be careful when you're writing program in C. If you're accessing an index that is not in your array, you should avoid it, because you are modifying a part of memory that does not belong to this array. What will happen is, imagine I have a lot of variables in my code, and God knows which variable I'm modifying by accessing 4 bytes after this 20 bytes of memory that I had for this allocated for this array. So be careful about that. Okay, let's delete this. When working with arrays, you're going to love for loops. They help you do a lot with arrays. If you remember, I said when we know the size that we wanted to loop through, we better use for loops. This is the case. Arrays, we know the size of them, and we wanted to loop through them, for example, to initialize all the elements in an array, and that's an amazing tool. I have a dedicated video to for loop. If you haven't watched that video, click on the card and watch that first. Let me show you how you can use a for loop to set every element to 4 in this array. For example, let me get rid of this. Okay, so for int I. So I'm creating an iterator. My iterator starts from 0, and then I'm looping through the array and incrementing my iterator. Inside the array, I can access all the indices by array bracket I and set it equal to 4. I create a for loop. This loop goes through the entire length of the array, which is 5, and set every element equal to 4. When the loop is done, it means that we have gone through the entire array indices 0, 1, 2, 3, and 4 and set all the elements to 4. You might want to write the condition as I less than or equal to 4, as we know that we're going from 0 to 4, but you know that both conditions are identical. So if I say I less than or equal to 4, or if I say I less than 5, they're both identical. It goes from 0 to 4. But the difference is each time the compiler gets to this point and wanted to check the condition, now that I have only less than, only one condition will be checked. If it was less than equal to 4, compiler has to check to see if it's less than 4 and if it's equal to 4. So I have 2 checks anytime I reach to this point. For a simple program like this, you won't even notice the difference. But we wanted to be optimized, and we wanted to learn writing optimized code. So it's better to have only one check. So now I wanted to debug this code. Let me put a breaking point here and F5 to start debugging. Okay, so now at this point, the array is being the array is being built and I is set to 0. And this line of code, this initializing by 4, hasn't been executed yet. If I click here and let's jump to the memory address of the array we just created. Okay, here. So now this memory address array, 1 byte, 2 byte, 3 byte, until 20 bytes does belong to this array. If I step over, let me actually pen this here. You see that the first 4 bytes now indicating 4. If I step over the loop another time, so now I is 1, I'm accessing the second element, offsetting 4 bytes from the beginning. Okay, and you see that the second one is changed to 4. Now if I step over and do the same thing for I equal to 2, which is I'm accessing the third element. Now I'm offsetting to 8 bytes rather than 4 bytes. Now here you see that after the byte number 8, I start changing 4 bytes. And it'll continue if I step over the code until I modify the 5th element here. And then the loop condition is not correct and we step over. Okay, perfect. There are other ways to initialize your array. We call it initialize a list. For example, I can say double x and set the size as 5 and just open the curly bracket and start typing 5 doubles. And 5.8, for example. Now I have 4. Let's add another one, 2.4. And then after the curly bracket, semicolon, of course. So now this array is created and initialized. Let's actually print. And we don't use LD because it's double LF. Let's actually print all the indices. Okay, so 1, 2, 3, and 1, 2, 3. Okay, so if I control F5 here, you would see that all the indices of X are initialized. The other way is just to let the compiler to decide the size. So I'll just say double X brackets. Let me actually delete this. Double X bracket. And after that, I'll use the initializer list and 1.1, for example, 2.2, and 3.3. Now, if we go ahead and we don't need these 2 lines as the size is not 5 anymore. And if I compile and run the code, you would see that x0, x1, and x2 are exactly the numbers that we initialized them with. Okay, perfect. The other way is to just have a high number, for example, 100. So now I'm saying double x 100, but I'm just initializing the first 3 of them. So it means that in this case, I'm just initializing index 0, 1, and 2, and the rest is just uninitialized. And one thing that you should note is that the size of an array cannot be a variable. For example, if I, instead of saying int array 5, if I said int a equal to int, let's name it property size 5, and then I put size here. Let me get rid of these printfs. Okay, you see that Visual Studio is showing an error to me. It said expression must have a constant value. So this size in your program, someone else can come here and say size plus plus, and this can change. It could be before and after the array, but the size of the array has to be constant. That's why Visual Studio doesn't allow you to do this. A fix would be sometimes you wanted to have a maximum limit for your arrays. You can use hash define max and put it equal to 100. And now here you can use max. The only reason I can do it here is because max is basically 100. During compile time, there is no max. Max would be replaced by 100. As you can see, expanded to 100. So I'm just creating an array of 100 integers. This is not the best way of doing it. The best way of doing it is to have a dynamically allocated memory so we can change the size. But right now, we're talking about the fixed size array. We will definitely have a video regarding dynamic allocation. In this video, we had a brief discussion about what are arrays in C programming. Arrays and pointers are tied together, and we can do a lot of stuff when we consider pointers and arrays together. So let's tune for the next video, arrays and pointers, and we'll talk about how to use pointers with arrays and how to pass them to functions. Thank you for watching this video, guys. Have a great day, and as always, see you in the next video.